Question 5 is all about trigonometry. We're given a triangle ABC. We're told that the length of AB is 2. The length of BC is 1. And we have to find AC, that is the third side, and we have to give our answer in surd form, that is as a square root with a whole number inside it. So there's only a few rules that we can actually use with right angle triangles. There's the trig ratios and there's Pythagoras Theorem. Since we have two sides and we're looking for a third side, that's automatically Pythagoras. So which one is the hypotenuse? It's always opposite the right angle, so this is the hypotenuse. And Pythagoras' theorem says that if you square the hypotenuse, so if you get 2 squared, it's the same as if you square the other two sides and add them together. So if you square 1, and if you take AC and square that. So we get 4 is equal to 1 plus AC squared. So you bring the 1 over and you get 3 is AC squared. And then you get root 3 is AC. So you undo the square root. The inverse operation is square rooting. Notice that our answer is a square root and we have a whole number inside it. That is what a surd is. Now we have to write cosine of the angle BAC. So cosine of this angle, we know that cosine of an angle is the adjacent divided by the hypotenuse. The adjacent is AC, root 3 as we just determined a moment ago. The hypotenuse is 2. And hence we have to find the angle BAC. So to find BAC, you use the inverse cosine of the same ratio, that is root 3 over 2. And so you can put that in your calculator, or you can take a look at the formula in tables book, and that will tell you that BAC is 30 degrees. Now we have to sketch a right-angled isosceles triangle in which the equal sides are 1 unit each, and use it to write cosine 45 in surd form. So we have a right-angled triangle like this. The equal sides are 1 unit each, so which sides are equal? Well, it's the two on either side of the 90 degrees. And because this is isosceles, you know that the other two angles are the same, and the sum of them and this 90 degrees has to be 180, so the only possible angles we can get here are 45 degrees and 45 degrees, and that shouldn't come as any surprise because we're asked about cosine of 45. We can use Pythagoras' theorem to figure out that the remaining side is root 2. And we have to use this to figure out cosine of 45. So let's say I'm talking about this 45 here. That's the adjacent divided by the hypotenuse. In this case, the adjacent is 1. The hypotenuse is root 2. So we've written cosine of 45 in surd form because we only have square roots and whole numbers involved in this. Lastly, we have to show that cosine of 75 does not equal cosine of 45 plus cosine of 30. Well, what's cosine of 75? If you just put that in your calculator, you'll get 0.2588 or thereabouts. So that's cosine of 75 degrees. We've got cosine of 45 degrees plus cosine of 30 degrees. And that's going to be 0.7071 or so, plus 0.8660. And if you add those two together, you get 1.5731. So the question is, when you add those two together, when you add cosine 45 and cosine 30, is it the same as if you just have cosine 75? Well, it's clearly not, because cosine 75 is 0.2588, whereas cosine of 45 plus cosine of 30 is 1.5731, about 6 times as big.